Hey everyone, Mr. Phil's Avatar here with another Devlog update. Today I'm covering a major milestone for Stellar Throne, my fourth X strategy game. For context, I'm building this with a dual-engine architecture using Godot for the UI client and Zig for the high-performance simulation engine. Yesterday's work was all about completing the Zig simulation engine and achieving full feature parity between the two systems. The main focus was finishing track 2 of the simulation implementation, which meant building out the remaining 21 simulation phases in Zig. When I started the day, I had just a handful of phases working. By the end, I had 100% feature coverage with all 21 phases fully operational. Let me walk through how this unfolded. I started by adding things like population growth mechanics, resource extraction, infrastructure maintenance, colony development, and fleet movement. That brought me to about 39% completion. These phases required careful implementation of the economic simulation, including resource production chains and population dynamics. Next, I tackled events like alien encounters and natural disasters. Then the quest system for narrative content, victory condition checking, empire-level diplomacy drift, and relationship changes over time. This pushed completion to 57%. Then I implemented the final 5 phases: military combat resolution, technology research progression, and the integration phase that ties everything together. Each phase required its own validation tests to ensure the mechanics worked correctly. With all 21 phases complete, I hit 100% feature coverage. But having all the phases working wasn't enough. I needed to load real game data instead of using hard-coded values, so I ported the TOML configuration system from my earlier Zig prototype. This involved creating a config loader that could parse TOML files for gameplay parameters, resource definitions, building stats, ship configurations, technology trees, events, and quest data. The config loader integration was substantial. I added 3 major loading functions: load gameplay for game balance parameters, load resources for economic data, and load content for events and quests. Then I migrated 7 simulation phases to use this real data instead of magic numbers. The config loader itself came in at over 800 lines of code. On the Godot side, I also migrated the research manager from JSON to TOML for consistency. This required updating how technology modifiers are parsed and ensuring all the existing tests still passed. But then I hit a problem. When I tried to run the Zig test suite, I discovered the tests had bit rotted. They were in the wrong directory structure and had 91 compilation errors. So I reorganized the entire test directory, moved everything into source/tests, fixed all the compilation errors, and created a test health monitoring script to prevent this from happening again. Once the tests compiled, I found 11 tests failing. These were mostly due to changes in the random number distribution, TOML parser bugs, and some logic errors in the probability calculations for events and quests. I fixed each one systematically, improved the pseudo-random distribution algorithm, fixed the TOML parser's handling of table arrays, corrected the event system's weighted random selection, and adjusted the colony growth and diplomacy drift calculations. With all the Zig tests passing, I moved on to the integration work. I created the Turn Simulation service in Godot, which acts as the bridge between the Godot UI and the Zig simulation engine. This service handles serializing the game state to JSON, calling the Zig simulation, and deserializing the results back into Godot objects. I also built a debug toggle that lets me switch between the Godot implementation and the Zig implementation at runtime for testing. The final step was creating a comprehensive parity testing framework. This framework runs the same turn through both engines and compares every single field in the game state to verify they produce identical results. I tested with scenarios ranging from 10 to 100 empires and 10 to 250 star systems. The parity results were interesting. I found several real implementation differences between the two engines. The Godot version has some bugs in how it calculates population growth and stability changes. The Zig version handles edge cases more correctly. But more importantly, I validated the performance improvement. The Zig engine runs 52.7 times faster than the Godot implementation for large galaxies. Here's what got committed yesterday. 22 commits total. The Zig simulation grew by over 5,000 lines of code across the turn simulator, data structures, and config loader. I added 9 new test files with over 2,000 lines of test coverage. On the Godot side, I added the turn simulation service at 376 lines, the debug toggle at 139 lines, and the Parity testing framework at 864 lines. The documentation also expanded significantly. I created detailed implementation summaries for phases 5, 7, 10 through 15, and 21. I wrote a comprehensive parity testing guide and a testing health monitoring guide. I documented the Track 2 completion and the turn simulation integration architecture. Current status. The Zig simulation engine has 100% feature parity with the Godot implementation. All 21 simulation phases are working. All Zig tests pass. The config loader successfully parses all game data from TOML files. The integration layer works correctly, and I have a parity testing framework that validates correctness while confirming a 52.7 times speedup. The next step is to resolve the parity differences. Some are legitimate bugs in the Godot version that need fixing. Others might be subtle differences in floating point calculations that need investigation. Once I achieve full parity, I can switch the game over to using the Zig engine by default and get that performance boost in production. That's the development update. Check out MrPhilGames.com for more. Thanks for watching.